Welcome to Probability Lesson 5, Sampling with and Sampling Without Replacement. In this particular lesson, we're going to have a look at the learning intention of looking at the concepts of sampling with replacement and sampling without replacement. And we have the learning intention of learning how to calculate event probabilities with changing data sets. So let's jump into it with an example. Consider you have a bucket containing 5 red and 5 blue marbles. You have 3 attempts of picking a marble from the bucket, recording the color and then returning it. So using a tree diagram, we're going to explain the process of picking marbles from the buckets. So recall the tree diagram that we learned in lesson 2, I believe, and we had use a black pen for this particular one. Here we go. So at each event we fork the tree into 2 different directions. So notice in the first one here, it's a case of you can either pick a blue or a red marble. So we'll say that the blue corresponds to this path here. In fact, I'll use a highlighter. That would be clearer, I believe. So the blue represents this path. And I'll decrease the size. And then once more. And then the purple, we'll say, represents the other path. As such. Now notice this would be the first attempt, and this would be the second attempt at sampling, and we want to keep trying to sample, so we want to have 3 attempts, so we'll go 1 more. And following the convention, we keep going down as such. Now this would be the basic structure of our tree diagram, and down here that's the 3rd attempt. So this is the basic structure of creating a tree diagram to represent the different possibilities of picking from a bucket of marbles containing 3 blue or 5 red and 3 blue. Now over here I've got a bit of a neater diagram. So now that we've got our tree diagram, we want to assign probabilities of the likelihood of, say, let's say picking a red, 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 blue, red, blue, red, and so on. But before we can do these bottom probabilities down here, we have to first understand what is the likelihood between picking a red marble and picking a blue marble. And if we recall back to lesson 1, it is as simply as saying the event or the likelihood of picking a red marble divided by the possibility of, or the entire data set, so the outcome. So it becomes, picking a red one is 3 divided by 3 plus 5, which is 8. And the likelihood of picking a blue marble, that's going to be 5 divided by the sample size, which is 8. So looking at this, we're more likely to be able to pick a blue marble here because the probability is much higher compared to the red one. Now going down at the 2nd attempt, the probability of picking a red marble, so remember when we pick a red marble we put it back in, so the probability of picking the red marble again is still the same as 3 over 8, and the one of picking the blue marble is 5 over 8. Now for the 3rd attempt, it is still the same as 3 over 8, and over here it is 5 over 8. Going across the tree here, the possibility of getting a red is 3 over 8, and the possibility of getting the blue is 5 over 8. Now consider we want to know what's the likelihood of picking, say, this combination here, red, blue, red. Well, we can calculate that by traveling down the tree. So I'll do that with a, let's say, a yellow highlighter, and traveling down the tree and asking ourselves what's the likelihood of getting this one. Well, as we travel down the tree, we collect each of these possibilities and we multiply them all together. So the probability of getting red, blue, red is going to be equal to 3 over 8 times 5 over 8 times 3 over 8, and bringing those all together, 8 times 8 times 8, what's that? Let's have a look. 8 times 8 times 8 is 512, and 3 times 5 times 3, well 3 times 3 is 9, 9 times 5 is 45, so the probability is 45 over 512, and to write that as a percentage, that's going to be 8.78 or 8.79%. So there's an 8.79% of picking the marbles in the sequence of red, blue, and red. So we would use this method here to figure out the probabilities of picking marbles, or picking using an event tree, a tree like this, to calculate the likelihood of sequencing events as such. So what about in a different situation where we were looking at, say, sampling but not returning the item that we picked from the sample back to the bucket? So consider tasting chocolates. So we've got a bucket and there's 14 Milky Ways and 10 Mars bars. You have 3 attempts at picking a chocolate from the tasting bucket. Now, what is the probability of picking 2 Mars bars and then a Milky Way? So let's draw the tree diagram over here. So over here I've got the tree diagram drawn up. Now the arrows that are drawn in blue, they represent the option of, or the option of picking the Milky Way, and the red bars are when we pick the Mars bars. Now what we need to do in here is we have to add the probabilities. So what I'm going to say is that notice on the first attempt here, so I'll write first attempt, there. Notice on the first attempt we have 14 Milky Way bars plus 10 Mars bars. So to pick a Milky Way, it's going to be a chance of 14 over 24. So 14, the amount of, or the amount of Milky Ways in the bucket, divided by the amount of Milky Ways plus the Mars bars, which is 24. And conversely, over in picking the Mars bar, there's 10 Mars bars in the bucket, so it's a chance of 10 in 24. Going down, picking a second Mars bar, or second Milky Way, sorry, notice that if you picked out a Milky Way on the first one, there's one less Milky Way in the bucket, which means that rather than 14 Milky Ways, you've only got 13. And rather than having 24 chocolates, you've only got 23. Conversely, if we pick at a Mars bar, because we haven't picked out a Mars bar yet, following the original path from here to here, we picked out a Milky Way, and now we're turning right, we're picking out the Mars bar. The chance of picking that Mars bar becomes 10 in 23. 23 again because we're one chocolate bar down because we grabbed the Milky Way on the first attempt. Now, following the tree further on the left, picking out 3 Milky Ways in a row, it is a chance of 12 over 22. And similarly, picking out 2 Milky Ways and then a Mars bar, that's going to be a chance of 10, because this would be the first Mars bar in 22. So the question at hand was, what is the probability of picking 2 Mars bars and a Milky Way? Well, we need to follow this path. There's 2 Mars bars and a Milky Way. So this path down here and down here. So if we calculate the probabilities for all of those, we've got 1 Mars bar on this part here. Now to get a second one, it will be a chance of 9 over 23, and then to get the Milky Way, it will be a chance of 14 in 23. Following the yellow path down, we get a chance of 14 in 22, and then to complete it, for this path, we'd get an 8 in 22 chance of getting the Mars bar. Now this is a oh, they're all M. So we'll just say red, red, blue again. That would be easier. So the chance of getting 2 Mars bars and a Milky Way, so probability of red, red, blue, is the same as saying 10 over 24 times 9 over 23 times 14 over 22. Say 10.38% chance. So there's a 10.38% chance in grabbing a Mars bar, and then a Mars bar, followed up by a Milky Way. So notice that when we sample where we can't replace, the data set or the probability, the calculation of doing the probability changes as we move further down the tree. So in summary, what we learned today was we learned how to describe the difference between sampling with replacement and sampling without replacement. And then we learned how to calculate probabilities of events occurring with both unchanging and changing dataset sizes.